teaching mathematics. But before we go on, the session will be recorded, so I need to get your permission for the recording to proceed. Do I have your permission, please? For the recording? Yeah, okay, thank you very much for and the goals for this session are, when I did my first year panel report, they say one of the things I have to do is to think more mathematically. That is, if I could, when staff use questions with voting systems, I need to know what kind of questions they use, how they create those questions. So if I get that conceptually, then it's easier for me to analyze how technology is being used for in the classroom, because that's what my research is focusing on. And secondly, one of my research questions for my thesis is exploring the difference between surface and deep learning. And having this kind of session is going to help me to see what's deep learning, what's surface learning. And thirdly, the kind of questions we're going to look at today, we plan to use Kara plans to incorporate some of the questions with voting systems. So basically, I'm not talking about what the questions are. I'm going to be giving you a list of 8 questions, just basic math questions in a first year level students. So I mean the A-level kind of questions. So what I want is feedback about whether those questions are procedural or conceptual. What do you think about the questions themselves? That when if students are presenting those kind of questions, what goes on in the students' head? How do they answer the questions? And how do you bring about learning? If you have any questions at any point in time, you can just interrupt me, because I'm going to get feedback from you and see what you think.
Are you going to clarify for us what you mean by procedural and conceptual?
Yes, that's a very good one. We have questions like, for instance, if you have a formula, you can just give the students a formula and say, this is it, apply it. You don't give them the reasons for the rule or the formula. But that's a basic definition. But the conceptual type of question would be or conceptual type of teaching or learning, where the students are presented the questions or the formula, but they're also given the reasons why, so and so and so. So it's about concepts, linking concepts, or linking patterns and things together. Instead of just leaving them disjointed without any connecting points. What I want to do is, when I give you the questions, then we can start thinking, because I know many people don't agree on what's conceptual or what's procedural. And when we start thinking about the questions I'm going to be showing, then we can start saying which ones are conceptual, which ones are procedural, and which ones are in between, which ones are in the gray areas, and what do you think as teachers with many years of experience. That's what I want you to do. First thing I want you to do for me, please, on your diagram before you there's one thing I want you to feel, if you can, voluntary. I want you to put years of experience you have teaching pure mathematics. Either secondary school level, elementary school level, university, college, years of experience teaching
math. This says brackets math.
That's the second one. There are 2 questions.
Oh, right.
The first one is pure mathematics. The second one is teaching maths to engineering students or science teaching. So there are 2.
How old am I now?
I'm taking it, Sam, that you want me to answer about mathematics.
Well, you don't teach.
Yes.
I don't teach mathematics.
You cannot exempt it. Or you can just put statistics. Replace it with statistics for the first one. I'll leave the second one blank because you're going to any engineering mathematics. The next question seems a little bit vague, but I just want to see what you think at the beginning. If you look at, first of all, my definition of conceptual and procedure, how many people were able to get that? My definition was procedure and was conceptual. How many people? Can you simplify by raising hands, please? Or just make an answer?
Yeah, I'm comment though.
Yeah? Did you get that?
Well, yeah, I think so, but I think it's a very difficult definition to apply.
Yeah.
I mean, I doubt there are any purely procedural things actually done with that
It's a mix. Are you saying it's a mix?
I'm saying I think it would be very difficult to draw a line between what was what in any given teaching and learning experience.
So if you wanted to estimate what kind of you're teaching, for instance, let's say, forget about pure mathematics, not to engineering mathematics. You wanted to estimate what percentage is procedure and what percentage is conceptual. Can you be able to do that?
Well, it might add up to more than 100. That's the problem, you see.
Yeah, what can you count? Maybe if you have 100. Is this something you could attend, Barbara?
I'll give it a shot.
I think it's quite hard, but it might be interesting to see what we come up with.
I just want to know, do you have the definition broad? Do you have the definition now to go and answer that, attempt to answer that question? The teaching you've done at the high school level, at college, basically what I said, that conceptual teaching is you give them reasons. why you have the rule or the formula, so that they can understand the thinking behind, like proof. You understand, this is it, but this is how we got there. But when you just give them the formula without giving them reason, say, anytime you come across this problem, apply this formula. They don't need to know how they got there. That's just a procedural type of teaching. Now, I want to estimate the kind of teaching you've done. For you personally, I'll estimate for teaching mathematics, which percentage you're going to procedural, which percentage should be conceptual.
Okay.
So it's just an estimate to begin.
Do you want them to add up to 100?
Give it the way it is for now, since we're exploring. Let's see what happens. Maths is an exact science. Is maths an exact science?
Is it a
That's
science?
another complicated question.
Yeah, please, actually, yeah, one philosophical question per seminar, please.
This is very interesting.
And do you want me to answer it as it's written?
Oh, this
I
is
think you can
difficult.
skip that because your statistics for.
Thank you.
Likely because you're a
And Sam, I'm sorry, this says maths teaching.
I was willing to do it.
See, the answer to me was perhaps a bit different if it were maths learn, you know, what
Well,
students might be supposed
maths
to do.
teaching, I don't put maths learning. If you
Okay.
think there's a dichotomy between maths teaching and maths
Okay.
learning, then put it
I'll write something else.
Yeah.
Okay.
That's what it's supposed to be. Anything thoughts that
Okay.
doesn't fit within that box,
Okay,
Just-
good.
eventually. Rod, are you with me? Are you?
I think you explained it in excellent manner.
Okay, thank you very much. Okay, so got to move on because I'm conscious. Again, I want to say thank you very much. This is lunchtime for most people, so I appreciate you coming here at this time.
They're giving you a hard time, Sam, aren't they? I think you're doing really well.
Yeah, thank you.
I wonder why you wrote them the other way around. You nearly
Maybe it's to
caught-
make sure we're awake.
you nearly caught me out there.
I'm not going to do that because
Yeah, you
I feel
were.
the stress tonight. I'm not-
Oh,
Engineering with
Oh,
the
dear.
Who else noticed? Who else noticed
Yeah,
this
maybe.
the other way around? Okay. That means, yeah. Because I didn't want you to go to procedural conceptual, just 25%, 75%. Then the next one you also do that. But if you have to think, then it kind of stretches your mind to say. My first question is it's just about a rule. And most people, you're maths teachers for a long time, so you understand what I'm trying to do here. So simplify base expression. And there's a rule to be applied there, it's just BODMAS. Or some people call
I
it
hate
a
those.
different name. So what I want you to do for this question is try to answer it as fast as you can, and then I'll just ask the question after that to follow.
What should I do? Simplify it.
Simplify that. Can you see experiment that? If you can't see, I'll explain anything you can see.
Am I supposed to be using one scrap paper for everything?
That's the rough paper for. You can use the other one.
Oh, so we don't have to write on the answer sheet?
You can
Oh,
use
I
the
see.
rough paper.
Oh,
That's what
so-
makes rough paper out
So you
for.
don't want
No.
No.
What
can
do you want
it
on?
that way. This is not to test knowledge. I want to see what you're doing. It's not, yeah, because it's real. Just, yeah. Okay. The question I want to ask is that how will you solve it as not as a teacher, as an individual? If you solve this question, how will you solve it in your head? Because sometimes we do things intuitively in our heads before we actually write it down. How will you solve this kind of question? I want to response feedback. What do you want?
I had to write it down. Again.
Okay.
I couldn't.
Yeah.
I don't think I could do that. I probably could have done it in my head, but
Yeah,
my natural instinct is to write it down.
okay.
And then I thought, like you said, I've got to think of a BODMAS rule and recognise that the two terms in the middle are the things I'm going to have to deal with first, and then process those before I did the final adding up the simplification.
The first thing that went through my head was whether there was some kind of quadratic, not formula, what do I mean? Completing the square thing going on, which of course I quickly rejected because there's no anything useful there. But that was the first thing that went through my head. Just because of the structure of this first bit.
Yeah.
I thought that as well.
Any other comments?
I thought this must be a mathematical trick, and I'm not up to it because I'm a statistician.
It's a cop-out student answer.
But then I realised that I ought to be doing the dividing first, and then it was all right.
Okay. We all teach it differently. If you want
Have we all got the same answer?
I don't know.
That's what I want.
Yeah, I want to know what the answer is.
Because I'm going to test it for knowledge, that's why. Okay, can we have these answers? Call out your answers, please.
X squared plus 21.
Everyone got to x squared plus 21. Okay. But that's what I'm saying, I wasn't testing for the knowledge. How will you teach this? If you wanted to teach a little bit the same way that you will solve it, if you want to explain it to students.
The way Tony explained it, I would teach the students, to say to them, we're thinking about Bodmas, and, so you start off with the bit in the middle. I mean, I actually asked this today of my students. Do you want me to report this at the moment, Sam, or not?
Yeah.
Is this one of your questions?
I used it, sorry, this is one of Sam's questions, so I said, I'm using Bodmas at the moment. I taught it last week, and I gave them that at the start just as a recap of last week. I put it up while they were coming into the class, and I said, try that while you're waiting. But I put 2 squared instead of x squared because I wanted a numerical entry. I was using voting systems. So I put 2 squared, so they should have got, what was it? Yeah, 25 then, yes. They must have done something different. The answer, well, maybe it was, I can't remember what I put, maybe it was what. Yeah, anyway. I thought the answer was 23 when they did it, maybe it was 25. But only about half of them got it right. And the other half got it
There's
wrong,
many things to
actually.
get wrong in there.
Yeah.
There's far too many minus signs.
Yeah.
Much potential for error in the minus signs, right?
Yeah, so a lot got it wrong actually. So it's out of
Okay.
interest.
Talking about it, Bodmas is a rule that you have to apply. It's a rule,
It's a convention.
a convention. Thank you, because I'm still getting my mathematical terminology right. So it's a convention.
I would call that a
move
convention
beyond
because
that.
then rules would also encompass rules that are sort of logically have to be that way, where this is a convention, we all choose to do it this way,
Yeah.
which has a different logical status within the theory.
Does everybody agree it's a convention?
I hadn't thought that it was a convention, but now Laura's
Yeah.
pointed it out, I think she's probably
It's a
right.
convention, okay.
Yeah.
So let's say conventions and rules. I'm not got to make distinction yet.
Yeah, fair
Just conventions. Let's say it's a convention. When students are taught this convention, for instance, that when you have this kind of expression, this is how you solve it. Take in consideration the convention. Now, do they need to understand the different elements? I mean, what I'm trying to ask is does it have to be conceptual? For instance, I know this is the rule, this is the convention, and I can solve it from using this Bodmas bracket, division, multiplication rate. Does it have to be, if the students get this, for instance, does it mean they understand concepts behind this? Like if you go to solve this particular problem, you have to understand minuses. When you 2 minuses multiplication, then you get a plus. Those part of concepts they need to
I
understand.
don't think it is. I think they can just answer that correctly by learning a rule or a convention.
I think they could, but it would take longer and be harder and be more prone to error, and that what you ought to be doing first is looking at it and thinking, what should I do first to make my life easier? Which involves recognising more of the structure and where the potential problems are. And what you can temporarily ignore.
What you're saying is that you need to understand some part of the concept for them to actually
Well, I don't know what
to
the,
make
I
it
don't know
easier
what
for
the
them.
concept is in this case.
All these
That's
10
why I'm
steps, all these sub-components, that's what you mean.
If we talk about meaning rather than concept, what does it mean? What we've got up there.
I mean, what I think with my students today was happening was they could understand Bodmas, is my reckoning, but there were things going on there other than Bodmas that they needed to know. So, for example, they need to know that when they divide by minus 5 over 2, it's the same as multiplying by minus 2 over 5. And I imagine a lot of them couldn't remember that. And then they need to know that minus 5 all squared becomes plus 25. And then that minus and the other minus multiply together to give you a plus. So there was Bodmas going on here, but there was a lot of other things. And it was very difficult then, when a lot of them got it wrong, I'm then left thinking, is it Bodmas they don't know? Have I not taught that well enough? Are you with me? Or is in fact, is it their underlying algebra underneath that, or arithmetic really, that is causing the problem? So I think this question actually tests lots of things. It could be lots of procedural things, I don't know, or we could say, I don't know, but it tests lots and lots of things, doesn't it? And I think that's why it's a difficult question, I think. It's quite demanding for students. They've got to know a lot there to be able to do it correctly.
But there are several procedures.
There are,
and,
exactly.
I don't know if this was what you were saying, Lara, but it seems to me that if you're going to learn procedure by procedure, which I see as being procedural learning,
Yes.
then there's a significant challenge in combining the procedures.
Yeah.
So it's not just a straightforward apply the procedures here, it's how do these different procedures that you might have learnt very well
Yes.
fit together to enable you to get a solution to that.
Thank you. So several procedures combined, you have to be able to understand how they link up together to be able to solve that question. Okay. Next question. This is about sequences. And I just asked them the question to find the sixth term. That's very easy. Well, that's very easy.
So you prejudged.
But
Can we do it?
I've seen I've come with some assumptions like this where was like nothing. You have to state your biases and assumptions when you're going to research. So I'm assuming you have years of experience here, maybe 100 years of experience or more of teaching mathematics right in this place right now. So, but yes, thank you. I'm clarifying that. So the sixth term is easy, but the next question can be, how do you find the next, the answer to the next one?
I would just apply a procedure.
Yeah, which procedure do you apply?
I just know a formula from my A-level days.
You know the formula, so you just, and it doesn't follow.
Well, you have to actually you have to have some knowledge. You have to recognise that that's an arithmetic progression.
Yeah.
I would have to first of all recall the procedure. I'm not sure that I could just write it down just like that.
Does it feel like a procedure to you?
And in,
Does
Just a process of
in
yeah.
bringing back the procedure, I think I would
Feel
feel
like-
working conceptually because I'd be saying, what does this mean?
Yes. If I just didn't know the formula imprinted on my brain, and lots of formulas I don't, I would work the formula out from scratch for the general term, and because I can remember the proofs of these things.
But don't you think that knowing the formula and being able to write it down carries with it something of the meaning within the formula? You see, I'm very sceptical about so-called procedural knowledge because unless you have some kind of perfect or near perfect memory, I just don't know how procedural knowledge is going to work for you in the long run. So I think when you recall the sum to whatever terms here, okay, you might be able to just write it down because you remembered it, but I think built into that memory is something about what the terms mean and how they apply to this and where they come from.
That's not how I experienced that at all, really, in terms of almost like doing it again from scratch. Like, well, you have 3 each time, so how many 3s? Well, we'll add to the 5. Right, that.
That's how Sam did it, because he
But
didn't
that-
know what isn't
But
possible.
that, I mean, it's equivalent to this
Yes.
formula, but it never occurred to me to think of a formula. I just
Right.
And I did it
went through that
slightly.
reasoning.
I did it slightly differently. I went to the third term and then thought there's 233s to add to that.
Yeah, I thought about doing that, and then I thought, you know what, I can't do. It's like adding dates in the year and working out how old you are. I lose track of. Do I want one more than this or less than this? So I know
That's
I'm
why
bad.
I went to third.
Well, so I
because
know I'm
knew
bad at
where I was.
Right, see, I was less confident to do that than I was to start with the first one and do 232 of them.
Yeah, I was less confident to do it.
Oh, in fact, I
that
got it
way.
wrong, look, because I misread the number, the digit.
See, what's very interesting
Yeah.
is people are tackling these things in very different ways. I just
Yeah.
went straight to a formula. I didn't think about anything other than just that fact that was it.
So what's the formula, as you remember it?
2a plus n minus 1d.
Yeah. Now that you say it, I remember that formula.
And I just know that because I've taught A-level maths for so long, but it's just in there. It's probably your brain as well.
How did I
isn't
start
it?
that formula?
2a plus n minus 1d.
Um,
Yeah,
that's
so
what
twice
we-
first term.
Yeah. How will you teach
Why
them?
do you twice the first
Yeah,
one?
I do it.
A plus.
Is it A? Have we got the wrong
Yeah.
formula wrong?
That makes no sense.
It's A plus n minus. It's A plus n minus 1d. I can't even do it. I can't even do it the wrong way, can I? A plus n minus 1d.
So if you got the formula
Oh, dear,
wrong,
Tony.
you get the answer wrong.
Rod was nothing. He didn't correct me, Rod.
How can I argue with you, Tony? Go on.
Oh, dear.
How will you teach this? Let's say you wanted to teach in the class and you give first year students, how will you teach this particular one?
I wouldn't, I'd just give it to them and say work it
The
out.
formula?
No, just give them that and say work it out.
And then they work it out, they don't get it, they don't get it right. How do you solve it for them? What do
I
you
get
give
to
them?
talk to each other about it. I reckon any class first years can sort this out among themselves.
Suppose you wanted to, you have to solve it, you wanted to show them how to do it. I understand that's your problem, but you wanted to show them how to do it. How do
You
do it?
can't ask me that question because that's just not something I would do.
Okay, I understand. Anyone else, if you wanted to teach this, how will you teach it?
This is an example of something. So do you mean how would I approach the concept in the first place?
I don't want to think concept or procedure. This is question. You want to teach sequence to
I
your
wouldn't teach.
students?
I wouldn't teach that.
You want to teach?
I wouldn't teach that.
Okay.
I might use it as an exercise, and if then people wanted to know more than just the answer,
Yeah.
then I think we would go back to concepts.
Okay. Anyone else? Right? Anything else? Right?
Yeah, I'm interested in Laura's approach really, because I think students get quite frustrated about this sometimes. There's pluses and minuses to what you say. You give them a problem, don't you? You say, sort it out. It could take them a long time, but they could have a lovely time doing it. And then as a student you think, I haven't got time to mess about like this, come on, we need something better. So I prefer a more rigorous approach where you show how they get it, and then let them apply that. So there's two things really, isn't there? The rigorous approach where you come up with Tony's formula, or there's let them loose on it, which has got a lot of merit, but have you got the time to do that?
Oh, I didn't say I would do that for absolutely everything.
I feel more reassured, I think, by coming up with the formula, doing 300 of them, and feeling really good inside, just like Tony, that I can do it.
I think they can come up with that formula and not experience it as a formula and not misremember it.
This is recorded, you know.
It's going on YouTube later on, isn't it? Time to
Yeah, that's that. Now, I don't come from a maths background, so I didn't have a formula to work with. But when I look at these and I was trying to understand, I say it's an arithmetic progression, so it's increasing by a constant term. So it's 3. So the best thing is to do is to, for me, is to find out what's the constant. It's 3. It's 3 there. So you just again divide the formula in terms of a constant term, which is 3n. If you say 3n, for instance, is the 5 is the first term. Say for the first term, you have to say 3n plus 2, and then you try to see if it applies throughout the whole sequence. And that's the way I got it. And you can change the sequence, change the series of numbers. I mean, the numbers you have the sequence, and you can just find if it's actually an arithmetic progression and it's increasing by a constant term. You can always find it. You don't need the formula. You derive your own formula that way. And that way, you could say it links more to conceptual things, because conceptual understanding of teaching, because no matter what you give to students, they can always find to say what's happening here. And based on that, they can understand what's happening, like they can derive it. So they don't need to remember the formula because they can get their own formulas. And the thing about, and also that's that, after arithmetic progression, if you have the formula like you say, A was A minus 1B, suppose it's decreasing, what happens? Because that formula doesn't apply for that. Do you have another formula for that?
No, it doesn't.
Yes, it does.
You just D is negative.
Decreasing negative.
Yeah, so you put the
Yeah.
so instead of plus
Yeah.
3, it would be minus 3 if it was going down by 3 each time. So it would still work.
Those are work for
But
them.
there is something about recalling the formula. You have to know that the formula you recall fits the...
She's doing it too. I just
I think that that's not just a procedural
No, absolutely.
thing that you do, because I think you have to look at that and say, what's going on here, which formula. Well, for me, I couldn't trot out a formula as Tony did, so I would have had to think that.
No, I'm thinking if you're teaching it and you tell them to see what the constant rates and derive it from that themselves, but at the end of the day, you still give them this is the general formula that applies for arithmetic progression. How about that?
I would want to do it that way. I would like to I might start with an example and say to the students, okay, we're going to try and work out the 233rd term of this, and we might go through it and derive a formula. But then I would go to the general case and say, okay, now let's look at it, rather than for every individual case having to re-derive it each time. Let's go to the general case and work out the formula, and then now we apply the formula. I think that's, probably what I try.
aiming for.
Can I ask about our approach to other people's ways? I mean, do we say, for example, that's not the way to do it, this is the way to do it, and yet over there, Mastermind, he came up with a wonderful way of doing it, didn't he? He didn't rely on the formula. And therefore, do we dismiss students who say, intuitively, oh, I can do it like this? And do we as teachers say, but you shouldn't do like that, you should use the formula or whatever? Yeah. I mean, do we accept all these other ways of doing it, just like we should? Yeah.
So the alternative options, like the formula, what you said, that Barbara said, you have to understand some of the underlying understanding. You have to have some underlying understanding to be able to apply the formula. But if you do it the other way, you let the students explore. They could actually come up with different formulas. For instance, there's not just one formula for this. You can have 2, 3, and to be all correct. And so the students, it frees the students to actually explore more options, and they still get at the correct answer. But that's just, let's move on to the next one. It's about sequence series. It's like, it's building on sequences. And you can, this question for instance, I don't think, what do you think about this question? Can students attempt this question without understanding what's going on? Because it builds on sequences.
How are you going to convince us as students that we need to know this? Anyway, come on. No, I mean, I'm asking you, this, why on earth should we know this? It's
Why should we know
fundamental.
it?
Yeah, why do we need to do this?
Because they're going to know statistics, they're going to meet Richard and he's going to show them lots of sigma signs, aren't you, Richard?
Are you saying
Probably not a sequence
you
like that.
need to do this, trust me? Is that what you're saying?
At this moment, implicitly, trust me. And I've not explored that question yet. So I will, like you understand, like I said, because there are many applications for this. You can come up, you can help me out with that. What happens that I don't think that in the mathematics, I need to think about, to read about it and to see how can you apply the sigma, the sigma notation in terms of finding series. But that's not where my strength is right now. So I'm just.
Oh, hang on. That's actually, sorry.
It's meaningless.
Yes.
isn't it?
What are you saying?
That should say,
Yeah, you shouldn't say that.
You shouldn't say that.
It's just sigma notation to find the sum of the first
It's the
six
sum.
Yeah.
Oh, yes, yes.
Okay. I'll change that later. This time. Thank you for that. Now, this is the next question. Which of the following?
Excuse me for a second. Can we just go back? Suppose that I haven't written it just as you've written it there, but I wrote 2n minus 1 from
And equals
Two.
2 then, yeah.
to
7.
7. Would that be okay?
Did you change it that way? You just give them the formula, so we can just substitute the numbers to get the sum. To get the sequence, and then whatever the time you
You see,
find.
I'm not sure what the formula is that I would give here.
Yeah.
Is there an expectation that it would be sigma from 1 to 6?
Yeah. That's what I said. For
See,
six
I-
times of the
No.
sequence.
no, well, yeah, not necessarily. You can,
You didn't.
yeah.
You could start with sigma going from 0 to 5 or
No,
1
the
to
n is
6
equal to 0.
or
I
2
want
to
n is
7.
equal to 1. That's what, for the first
Okay.
one.
Okay,
Yeah.
right. I think this is difficult though because when I was asking the students, I was teaching this last week, and I didn't have this question at the time, but I was doing it the other way. I gave them a sigma notation and asked them to find the sum.
If in doubt,
And
write
they
it
can
out.
do that all right, by and large. But I think this is a much more difficult way to actually start with a sequence and say write down the sigma notation. And I think, you know, they have to understand a lot more to actually go this way. So
I
think
agree.
it's
And
quite
if I was
difficult.
trying to get them to think conceptually, I would actually be saying use sigma notation to write this in two different ways.
Yes.
One of them of which starts with n is 10 or something
Yes.
like that.
Yeah.
Mm.
Because then you've got to really unpack what's
Yeah.
going on and
Yeah.
understand it.
Yeah.
So you're saying this is conceptual?
Well,
More
it could
conceptual.
be. You could develop it into a conceptual type question.
I mean, it seems to me that as we talk, we're saying very little that's just procedural.
I think that, but in relation to that, so one of the things about going in the sort of forwards direction, if you like, of writing one of these out, I would say, is that it can be done more or less procedurally. In some sense, you know, put n equals 1 in there, put n equals 2 in there, put n equals 3 in there, write them all out, add them all up. But going in the other direction requires some choices. That's what I see as the key difference that makes it hard. It doesn't
Yes.
require you to really know a great deal more about how to represent numbers as letters or vice versa. But what it does require you to do is make some choices about how you're going to do that. And that suddenly puts you in a situation where you have to really engage with it and test some things and try some things and see if it works and see if it doesn't. And that sort of somehow is a larger load. That's
Yeah, because going
my feeling about
the-
it.
from the sum to actually writing out the terms, you give them the direction essentially in which
Yeah.
way you've got to go, don't you?
Yes.
There's only essentially one way you're going to do that. Whereas you've got an infinite choice of ways of doing it the other way around, haven't you?
Barbara, in response to your question, it was because I wanted to get it more conceptual. So you have to think about what kind of feedback we get to have this kind of question. Rather than essentially land more towards conceptual than procedural. But I wanted to see what the feedback is. Am I applying this conceptual or leaning more towards conceptual? Meanwhile, it might be procedural. That's why this bias seems to be coming out. This is the next question. Which of the following produces a straight line graph? Now I'm just trying to see when students say they have misconceptions about what's a linear equation or a linear function. So sometimes when you mix the terms around, they might get confused because they are used to finding in a particular way, particular format. Y is equal to mx plus b or mx plus c. So I'm trying to say for students. All you can see the right.
The dots mean multiplication, right?
But the dots is question 1 and question 2.
He just
Read it
he
constantly.
just say number one.
I
number
knew
two.
that. I simultaneously read them as two different things. That's so funny. It's like it went twice into two separate. I read that as number 2. I read it as 2 times minus 2x equals blah. But that was after I'd already read that number 2 once. It was like it went simultaneously into 2 brain slots. Brilliant. Being a student's quite hard, isn't it?
Where do you think the students will struggle? Or which which expressions do you think they are problems with? Right?
None.
I don't think
No?
that's true. No, not particularly. If they've got a minimal level of knowledge there's not much thinking to do.
I disagree slightly.
Do you?
They get it wrong. I did something like this last
I
week.
think
They were
they
getting
They
it
get
wrong.
the 6 that they get wrong.
The 6 over x they get wrong.
They think that's
That
the
one, yeah. And even the others, like the root x and the x squared, they're not, because you give them this and you maybe don't know, you just say, well, you've all met linear equations and it's to do with a straight line and y equals mx plus c. Now let's see if we can now it depends how much I think you teach in advance, Tony. If you give the question after maybe just stating it but not labouring the point that you can only have x to the power 1 and y to the power 1, so I think it depends what's gone on beforehand. If you just sort of state it, here's a linear equation, a general linear equation, which of these fall into that category, then I think they struggle because suddenly they don't know what to do with root x and 1 over x. But if you sort of labour it and you teach it and you say, okay, for a linear equation we're only allowed x to the power 1 and y to the power 1, do you know what I mean? And it can't be x multiplied by y. So
See, I know that
think a
some
lot-
students would find that 5, they would argue that was an x to the power 1 as well, isn't it?
Well, they would exactly, that's right, that's
Yeah.
why 5 I think is particularly difficult, yeah.
And 6
Well, I
as
think
well, because they just don't
6.
recognise
Yes,
that.
and 6,
Yeah,
that's right, yeah.
6 is
Doesn't
a
have the x
nightmare
term in
in
it, yeah.
linear regression.
I mean, Rob, what would you think? Because you probably taught this a lot at school, haven't you?
I think it's 100% procedural.
Right,
That's what I would think. And they've got in their minds y equals mx plus c.
right.
And you just look flashing along there looking for that sort of form.
Right, which you don't find in any of those.
No.
In its literal form. So my experience is that a lot of people, most students, I'm saying most like I'm convinced, but I think I still am convinced, we meet the formula as y equals mx plus c. They're used to seeing it in that form, they're not used to seeing it in the form, however, whatever the standard letters are, ax plus by equals c or whatever it is. So there's that effect. There's also the sort of, has anyone read that visual salience paper? We talked about that in there by Kirshner. If you look at y equals, number 3, y equals root x plus 6, there's a definitely different symbol in there that really stands out as something like I'm a bit uncertain about, so it makes me uncertain. If you look at the y equals 6 over x plus 10, okay, so there's that bar, but it looks like, it doesn't look particularly like you're doing anything with it. It looks a lot like a formula that says y equals something x plus c, just visually without any, other processing going on. That's kind of what it looks like, so I can see why they make that mistake on that one all the time. So at least 2 things going on there, I would say, that you've got to sort of overcome in order to get this right.
I think you're right, but I think it's procedural. If you've taught it thoroughly, this is why I was saying I think it depends what the teacher's done in advance. If the teacher just put up, y equals mx plus c is the equation of a straight line, which represents straight lines from this
Not
slot.
mean very much, would it?
Well, exactly, that's right, because they wouldn't kind of think about rearranging and everything, but if you've taught it, if you've had lessons and you're teaching it all and then you put it up, I agree, and you've rearranged things into different formats. And I think it depends a lot on what's gone beforehand, doesn't it?
This lends itself to investigation, doesn't it? What does the bit before the x do and
Yeah.
what does the bit on the end do? But yes.
So you were saying when this is rearranged, when separate from the amount of way it's presented, students don't struggle. What happens in class? Have you noticed that, or the struggle that even if you taught them well, instead of saying y is equal to mx plus, you can put the terms to the other side?
Depends on the ability.
Okay.
That first one, number 1, if they've got a reasonable amount of ability, they cope with that all right, I think.
Okay. Just to explain. Thank you.
I want to substitute for things there. I'm looking at 1 over x and thinking, well, if you call that t, I've got a straight line.
From the statistician's
There's always
corner.
one, isn't there?
What's wrong with that? What's wrong with that?
I had two paired questions, 5A and 5B. This one is just sketch the graph, and I'm thinking, excuse me, that's procedure. Is a procedure, I don't want to be, is a procedure just sketch the graph? But my understanding just substitute the values. But what if you give them some graphs, how you can make them out, the lines, and tell them to say, the questions on the top, sorry, it's not very clear. Which line represents y is equal to minus 3x minus 3? They now have to decide out of about five straight lines that I got there. So you need to understand what's happening there. That's what I think. If you were to say which line represents, that's easy. Represent y is equal to minus 3x minus 3. Because we talk about the equation of a straight line gives you the grade, the slope, the intercept. With that, you can easily eliminate some options here and know which one is the one. But what I'm trying to get at is they need to understand what's happening. Understand what the rule is. So is that conventional rule? Y is equal to minus x plus 3? The formula.
Well, the way we draw graphs is convention, right? We don't have to put the x on the axis and y on the axis. We just will do. I think there's other issues that are more interesting here, though.
Yeah.
One of which is the scale and the fact that people tend to be expecting scales to be the same on both axes, so none of them actually looks like that by that judgment. One of which is this choice of example where you've got the coefficient and the whatever it's called intercept are both the same, which if you wanted to really distinguish things, you might choose to ask a question in which those were different in order to be able to make that clearer. It's different. Going for that kind of thinking.
Sorry.
I was going to say, do you automatically assume that the x and y axis meet at the origin? I wouldn't as a statistician.
No, but I think at this sort of level you might. Would you not?
I wouldn't, no.
At this sort of level.
I'd expect a scale on it to show it. That in statistical terms, that diagram would be wrong because it doesn't have a scale. Yeah,
Right,
unspecified. Yeah.
But if we label them X and Y, the convention is usually that X and Y
Yeah.
intersect with zero.
It wouldn't be in statistics. That's yeah.
So what do you think was happening when students are presenting this kind of problem? Easy for them to get it?
One of the
or
things
is
that's
it
interesting is when you've got lots of lines on the board, you can compare them and think, oh well, that can't be right.
Yeah.
And I wonder if an interesting question would be to reveal A, B, C, D, E, F, whatever, one at a time, and to tell the students to press their buzzers or whatever
Yeah.
when they see the correct graph, so that they can't actually see them all and compare them.
Okay.
So you show A first and say, is this minus 3x minus 3? And some people might think it is, it's got a negative gradient or whatever, and they choose A, but they haven't seen the other ones yet. And then you show them B, and maybe they don't do anything. C, and then maybe some more press it. I don't know, just
Yes,
a thought.
good.
I don't think you can actually do that with this, because I don't think with the tablet you can get it to appear bit by bit, can you?
I don't know.
That's the only thing. You could maybe do it some other way in PowerPoint, but if you're doing it with a tablet and drawing it, I don't, because it either seems to be all there once you've drawn it or not
I'm not
there.
sure if you use translation. Can
What would
you
you
do that?
Pardon?
With translation? With PowerPoint presentation?
If you draw it live, are you
You
talking
could
about
draw live,
getting in having something that would work with the gizmos?
Yes.
That's a different issue.
Yeah, well, that's what Tony was saying about the
Yeah,
voting
okay.
coming in bit by bit. It is a different issue, you're right. Sorry, what were you saying about transition style?
It's just PowerPoint.
You
Yeah,
can
okay.
you can use this in yeah.
Transitions on the slide.
This next one, yeah, thank you.
A point can't have slopes. Sorry.
Thank you. I was just getting my question, so yeah.
Because I teach analysis, we get very picky.
There's a line that has a slope, not a point.
Not the point has a slope, yeah.
The point,
Also, students in this country are more used to hearing gradient than slope.
That's slope, yeah.
Slope in the States, gradient. I confuse a whole class full of American students by saying gradient and no idea what he's talking about.
That probably explains why
Well, they don't say it.
in regression, because I always call it slope.
They tend to call it gradient for most of schools. Is that right, Rod?
No.
No. Oh, I thought they did.
The term gradient is used widely, but slope is also used.
Oh, is it?
I find that. Do you find
In
that?
that case, I can blame them for it.
They're both used. In textbooks, gradient is used
More,
mainly,
is it?
I think.
Yeah.
Is this purely procedural question?
Great question.
Yeah, I mean, if in my mind, if I was trying to think of something that was a bit more conceptually demanding, and I would sort of, I mean, at one level, that's a sort of almost procedural question. You do need to do some thinking and have some choices, but it's almost procedural. But you could, to make them more conceptual, you could start to introduce things like, find the equation of a line which is parallel to perpendicular to this line or that line, and distance so much from the origin, or I don't know. You can
What
make
level are
something
you
more
teaching that
complicated.
at? What level? What kind of students are you teaching?
The same students, but something a bit more demanding.
Because what we found out that, like I was in Barbara's class for equation of a straight line, this one in the classes they only see organizing. And these guys are first years course technology.
This
And
was
they-
science. It's
What
the
science,
workshops,
sorry.
Barbara Randall's workshops.
Yeah.
Is it? Oh right, yeah.
Someone said they must meet some cross multiplication before. So when you go to that next line of thinking, it's actually beyond them. And that's it. So I want to start from, like I said when at the beginning, I want to see like A level, remedial, to revising what you're doing. So I'll incorporate your station for if I want to go higher in a higher level of thinking. I would just think of these people who have problems, think in basic things. So we'll see what kind of conceptual questions and learning and teaching can we do at that level to get them thinking so they can move to the next level. That's what I say that that's where the purpose of the question is.
Is it?
Generally.
I'm going to say something that I might not agree with, but I'll try it. So my general feeling about conceptual questions about a certain topic is that on the whole you are asking, if you want conceptual questions, you're asking them at a higher level because you want students to do some things which will encourage them to get a lot of practice at the procedural level in service of answering this higher level conceptual question.
Yeah.
Which
That's a nice way to think
means
about it.
that, so for instance, I might Tony's is one level up, but you could still learn procedures for doing that. What you might do is a more open question, sort of one like this, is say, give an example of the equation of a straight line that crosses the x-axis at a positive number. And then you could say, and crosses the y-axis at a negative number, or something. And then suddenly you've got lots of choice. But you'd have to do a lot of calculations similar to this, probably, to work that out. And maybe we want to draw a graph first, and then work out what kind of thing has that kind of thing, and what are we looking for, and what can you change, and what can you not change. But you would be doing a lot of calculations at that level to answer the higher level, more open, more, if you like, conceptual question. That's sort of how I think about what conceptual questions are sort of for.
I would conjecture that that's where we want people to be, isn't it? We're working in that sort of domain, isn't it? Of being able to sort of take these much more general questions and construct their own.
Sort of work out what to do. Not that I don't want them to practice this kind of thing, but on the whole, I might want them to do it in a context where they feel like they're solving some larger problem, so that they don't think it's a lot of exercises that are all the same. And they're somehow working on those kind of high level. How are we going? Kind of planning skills. Like how are we going to approach this kind of questions? That's something about relationships between those for me.
Yes. Tony, how would you suggest I do that? I wanted to go to the next level, create those questions.
I wasn't suggesting for a minute that you should do that, Sam. I was just thinking that that if you were going to develop more sophisticated question types, that's the sort of thing that one should be thinking of.
I think most people would find it quite hard, actually.
This one.
Yeah. Even perhaps some of the A-level kids would find it hard. Would they not?
I don't know.
I think the first years would tackle that, right?
I'm teaching next week. I can always put that in.
Well, what's hard? I don't really know what's very hard about that, provided you know that y equals mx plus c.
Yeah.
I don't know what's hard about that.
Which numbers you put where and stuff like this, isn't it?
Okay.
Would you think they would struggle, Rod?
Yeah.
Getting the c-intercept, the 0 minus 2 written that way rather than saying intercept c, do you think seeing it as 0 minus 2 will throw them?
Maybe it would. Would they recognise that is the intercept? They should do,
No, well they might not to start. I didn't think they necessarily
Well, you
would.
don't have to recognise that it's
They
the
could do-
intercept. You
yeah.
just
They
notice
would
a point on the line, don't you? And you've got the m already, so you just
And then just bring it into the equation.
turn
to
your
get what
find
it is.
c. Yeah.
Yeah. So the first thing is you've got to put it in the form y equals mx plus c with negative 3 in there.
Yeah.
And then you substitute in 0 and negative 2.
whatever they are, yes,
Yeah.
you'll find the value of C.
Yeah.
Just that that's very procedural in my mind. It's just provided you know one formula.
Yeah.
But-
Would the graduates be able to do what percentage would be able to do that then, do you think?
Very good question.
This question I didn't even think it was conceptual. It should be procedural. If you understand why Isotainous will say you can substitute the values and do it all
Yeah.
around and do it. But most people, lots of them struggle. The good students will struggle with this. A lot of these guys who are in sports science or places like that.
I would think if you asked our maths degree students, they would all be able to do that first year
Right.
maths degree on a diagnostic test.
Yeah.
But if you asked,
engineering types.
well, engineering is a very broad church, isn't it? But if you
Mm.
the weaker end of engineering, some of them would be able to do that.
Okay. What about in the handbook, sorry? In the handbook, I noticed they don't have questions like this. You just have, they give them 2 points, coordinates. They give them the values for 2 coordinates, so they don't have. I'm thinking that if it's procedural, if the student understand the question, the question was from a procedural perspective, and they are used to being given 2 coordinates, and they're not given 1 coordinate on a slope. And they say, what should I do? Until they know why 2 to m is to C, it doesn't come to them that they should actually apply the formula to be able to answer this question. That's what I was thinking. That's why I gave this question instead of 2 coordinates. And I am, yes, right here. Okay, thank you. The next question is, now they have 2 coordinates. I've solved with 2 points, the coordinates for the 2 points, and it's supposed to be straightforward, but I don't ask them for the question with straight line. I'll just say they need to find the y-intercept.
I think you've got to
Just
typo in the last
yeah.
question.
Yeah.
But should that be the distance between the 2 points at the end, Sam?
So you think they need to find a balance and then either way.
Does everyone do this by plugging stuff in formulas, or do you get graphs?
Oh,
My-
actually,
sorry.
we've given too easy a point, haven't we? The 0 2
So
actually gives you the intercept straight away, doesn't it?
Yeah, but that
Yeah.
itself is pretty interesting, right? Because then you can have a discussion about, well, actually, could we have done this more easily because we've already got some extra information from this kind of thing. I think that's quite interesting
Oh, right,
from that point of
yeah.
view. You know, because everyone bungs it all in the formula and off they go, and you know, then it's sort of an interesting thing. Like, well, did anyone stop and think? You know,
I
perhaps
would have
actually we don't
sketched
need.
it first.
Yeah.
I just, in my instinct, would just say, just get a feel for it.
How common is that though, Tony?
I don't know.
We
Not
can
very, I don't
recommend
think.
it,
I
can't
would,
we?
yeah, I wouldn't have sketched.
No, I think it's very, very interesting to see how different
Yeah.
people approach it.
Oh,
'Cause my instinct would have been just to draw a sketch.
Exactly. I would.
Right.
Well,
I'll
good
do
done,
so. Barbara?
I would probably have sketched it, but I was also envisaging a right angle triangle between the 2 points.
Yeah, I was sort of thinking
Via your
Well,
sketch,
because of the
Barbara,
last question.
You get that from your sketch, wouldn't you?
Well, I was having a mental sketch.
See, it's
so
actually
I
much
wouldn't
easier then,
necessarily-
because you can see the gradient, can't you?
Is that dangerous though?
Oh, very.
Depends how good you are.
Yes, I mean, but I think I'm wise enough to know when it gets so complicated that I would make a mistake.
Right.
I think.
Okay, let's go to the final question. And I have 2 paired questions again. I don't know which one is the better format. Here, I'm trying to get the notation and the way I ask the questions right. So it's just about gradients or slope, the slope values.
When you say how did it affect it, do you mean what does it tell us about the
What
gradient?
does it tell us
So,
about the
okay.
gradients? Yeah.
Does anybody else get the urge to go, what's like that, innit? When faced with questions like this. That was that way, that was that way.
And then the other question, the same set of alternatives. The other question is this one.
Oh, see, that's what it meant, okay. That's a clearer question, I think. I might add a question to the end of that.
I'd be trying to, if I was looking at this, I'd be trying to think, what sort of questions might you ask that would sort of probe a student's knowledge a bit more deeply? So, for example, if you're on a bicycle and this line represented a hill, which one of these would be the most difficult to cycle on?
There's a problem with hills, isn't there? In that you don't measure across and up, you measure up and along the road.
Do you?
Yeah.
Oh, I didn't know that.
That's right.
Yeah, that's
What's
right.
that?
Yeah.
What's that
Do
right?
you really? Well, I suppose that's easier, isn't it? Because it saves
I
you.
mean, when you get these figures on
Really?
One in-
triangle signs,
1 in 12. It's not the, I don't think it's the tangent, is it?
No,
No, it's
it's a sign.
it's the
Yeah.
same.
Is
yes.
it?
Yeah.
Yes,
1 in
that's
12.
right.
well, I
I'm
never knew
34
that.
and I never knew that. Oh, you're in North. I mean, he never knew that either.
Can you say that again for the camera, please? Can you say that again for the camera? Just restate it. What you said about the slope.
I can't remember where it came from now. I mean, what I was saying was if you're getting somebody said something about cycling up a hill.
Yeah.
And what I said was, if you're cycling up a hill in reality, rather than doing it on the page of your textbook, then you don't measure across and up to get the gradient. You measure up and along the road.
Oh, I never knew that.
I never
And
knew
what
that.
I'd never thought of was when
True.
they
One in
tell
12.
you it's a percentage. It isn't a
No.
percentage.
Extraordinary.
1 up in 12 along.
And universe of it,
Oh,
I never
right.
thought of the
Like
second
some
one.
history.
Is it percentage now? Is that the same thing? If you say like a, you know,
Well, what's
an
the-
8%, 1%,
Well, that's definitely
you know, how is
something.
that done the same way, I presume?
I never knew that.
Okay.
Not sure.
Thank you very much.
One in
Do you think, I was thinking about the gradient, like the values, like it's 2 over 3. When x increases by a unit of 1, for instance, y is going to increase by 2 over 3.
See, I wasn't thinking like that at all. I was thinking of which is the
Which
biggest
one?
number, which is the biggest coefficient.
Oh, no.
I wasn't thinking of x going up by 1 and y going
I
up by
thought
3.
like Barbara.
Okay, so I think that's the
Those-
question right.
Yeah.
As you go through the 3, they do that.
Yeah. This one's just happens that way. Yeah. But not very much.
I
What
think,
are they?
I think it's fascinating that people have very different thought processes about the same thing. So you can imagine in your class of 100 the different thought processes going on in there.
I'm becoming more and more convinced that I want to use the
for the staff.
Yeah, just the way that it makes you think
Yeah.
about the questions. I think you've got a lovely set of questions here. Well done. That's been a really interesting half hour.
That's all.
That brings us to that's the last slide. I just wanted to do something for me. At the end of something, there's a feedback in the section. What do you think are the strengths, what the weaknesses, and suggestions? You know what they have about 3 minutes
Did
to
you
do
want
that.
us to write something in the question?
No, I'll touch if you add something, but it was supposed to be.
This depends on the purpose of the session.
The last bit on feedback in session, strengths, weaknesses, suggestions,
But it depends on the purpose of the session. You mean this session?
this session, yeah.
But I don't know how to assess whether it was what its strengths were because I don't know what it was supposed to achieve.
What are your thoughts about what happened? I wanted to find out what's your feedback on the questions you used. There's a conceptual and procedural questions, and I use it in mathematics. Which one's the procedures and conceptual? What happens when people teach it? I just want your thoughts. I don't want it to be scripted. In the sense that whatever you think about it, so I can bring that on board when I do the next one with the students.
Do
I
you
can-
want us to have any discussion about these figures that we're writing down, these percentages that we're writing down?
That'd be good to at the end of the year.
Because, you know, we're all bringing some kind of thinking to what we write. You know, and if you look at mine, I've written 1395. Well, why have I chosen
It's
to
in that files. Yeah.
And there's this magnificent word should in here.
I thought that as well.
What percentage of maths teaching should be procedural conceptual?
I think I might revise my figures after this section, actually.
That's what
That's the point,
I have
that's
2
it.
points. There's another one at the bottom.
Oh, so
See,
there is. Oh,
you
right,
have to
so
do it
I'll
twice.
revise afterwards.
So
Right,
you
okay.
can see there's different discrepancy between what you put at the beginning and at the end of the session, what percentage of math teachers should be procedural conceptual. And we have 5 minutes, 3 minutes, because I don't want it to be right on the dot. Just like Barbara suggested, just any thoughts, constant thoughts or remarks about what you think about procedure, what you put down for procedure and conceptual, percentage-wise, why do you think that's where it should be. And then Barbara has finished, we can start. You finished? You just, I mean, what you said about, you wanted to talk
No,
about
I know what you
the
mean.
percentage. I just
Yeah.
wanted to say something about why you wrote what you wrote down.
I have something to say about that. Come on.
Yeah.
Just that my figures for what teaching should be like is almost entirely conceptual. Because I want people to be thinking about why should this be like this, so they don't just go away and forget or get confused or muddle up the formulas or whatever. And I want them to have that sense that this means something. But nonetheless, people do need to do some practice. I just don't think they need to do it in the room with me there. So on the whole, I would want the students to do some more practice of routine things, but I don't feel I need to be there for that. So the learning of it might involve more of that, more applying procedures than the teaching of it for me at this level, at least less experienced teaching, no doubt, but I think I would probably do something.
And how did the students react to that?
To what? Well, it's difficult to say really, because I mean lectures is kind of a bit like that anyway. I mean, nobody has tons of time for allowing students to do a load of routine exercises during lecture time.
But if they feel comfortable doing that, and reassured by doing that, and that's what they want,
yeah.
Who are you to say that they should do it like
I'm the teacher.
Well, don't you ask
I
them
don't
though?
see a problem with that. I mean, I see it as part of my job to help people get away from their comfort zone of doing lots of boring routine things and
Right.
get into thinking about it more. And I think there's other ways to support people in doing that rather than just giving them what they think they want.
Sorry, let me just say because of the time.
Oh, sorry.
Do you want to
No, it's getting interesting.
I know,
It's gonna be a long conversation.
because I'm conscious about I don't want it to be
No,
1 second.
thank you, Sam.
Do you have anything to say about procedural and conceptual, what you wrote down on the sheet before you?
I think I started with high conceptual and low procedural,
Yeah.
but I've evened it up now.
You've even enough.
How do you
Carol?
want
I'm the opposite. I started with, I was thinking, that I taught with lots of procedural, doing lots of examples, but having heard Barbara talk about how really within even what we think is a procedure, like recalling a formula and all the meaning with it, I think a lot of what I was regarded as procedural, I would now think there's actually more conceptual work in it than I thought. So I've actually switched the other way and think that I teach really conceptually now. So when I came in, I thought I taught really procedurally.
Tony, please.
I've shifted more towards the conceptual.
Conceptual. Barbara?
I wrote down the same.
You were saying too much conceptual. This was this guy saying that we furnish. Scales vary conceptual.
We
just
can't
can't.
even measure that. I mean, that's just.
You see, I think Skemp is saying something different from what you've asked us. You've asked us about teaching. What Skemp is saying is about learning. And, I come back to what Lara's saying. We have to take the responsibility of being the teacher and making decisions within that about what we're trying to achieve. So I've just written down a couple of things which says it depends actually what I'm trying to achieve at any point. And so I could see circumstances where, despite the fact that I'm really wanting what we're doing to be conceptually rooted, I might be saying, but notice if you do this, this, this and this, you get what you want. And I think sometimes the this, and this can actually be helpful.
I'm not for conceptual, sir, because like it says here, you see process accounting is actually the process, that's a procedure. People get some.
They distinguish
Get the
between
numbers.
process and procedure actually, but don't they? Maybe not on that one.
But they will leave that. There's this show on BBC, as I round up now, the BBC show on the maths, the story of mathematics, and they're talking about something French law, mathematician Baltimore or something, I don't know if I got the name right. And he likes to play with numbers, that was procedure. But in playing with numbers, he discovered a formula or something, that where if you take a prime number, if it's divided by 4, and we have a remainder of 1, it can always be reproduced or rewritten as squares of 2 numbers. And you just play with numbers. You just play with numbers. You do lots of procedures. If you do that, and with the right kind of teaching, like you said, it leads to formational concepts and conceptual teaching and understanding.
So I don't think there's a right kind of teaching.
I'm not saying it is. I'm just saying procedures should be minimized. It's part of the process.
Is that a judgment that you're making, Sam? Because if it is, that is quite strong. And even if all of us agree with it, if you're going to write it in your thesis, you will want to justify it.
I'm not saying that's my position.
Okay.
I'm just
Well,
putting it out.
it sounded like you were for a minute.
And I would be
It's
aware
not
of the
right.
should,
Yeah.
because I think rarely I want to say should.
Sure.
Me too. Certainly one
Can I ask you about assessment? For the students, assessment. What percentage of assessment is based upon concepts?
Well, that's difficult,
It is
isn't it?
procedures.
Because these questions are like assessment questions, aren't they? And we've struggled today to say which of these questions are conceptual and procedural, haven't we? So I think it's difficult to say in an exam what is procedural and what is
You see, I'm not
conceptual.
sure you can look at a question and say, I don't know if conceptual procedure is a property of a question.
No, I don't think.
I don't think you can just look at a question and say that.
I think
there is something about what you do with it and how you think about doing it, which is to do with the learner and the doing. And I think that's quite different from thinking about teaching what's involved in tackling that question.
So how would you categorise, Craig? This is something that Sam and I are wanting to do then. So like, we're going to, Sam's going to talk to other mathematicians that have done voting systems questions, and we want to essentially assess with different questions which ones are in some ways good questions and which ones, you know, are not so good, if I can put it that way. And good questions are ones that are maybe like, you know, testing the concept in the way Lara put it, you know, it's a number of sort of procedures you've maybe got to link together. So if we don't categorise it as procedural or conceptual, how could we sort of categorise questions then?
This is really making me think that there are situations in which as a teacher I'm not prepared to say a question itself everyone in the class will have to tackle without, in some inventive way, without using a procedure because we simply haven't looked at one. So that's an easier distinction to make as a teacher. But
a word that we haven't used, or at least I think we haven't, is the word skill. And I think there are skills that students have to have in using mathematics. And I think we're not doing them any favours if we don't encourage them to be aware of such skills. Now, I don't know whether we could go back and look through those questions and say what are the skills that students need in order to be able to answer those questions. Now, I feel that when I'm talking about skills, I'm getting into something that's more procedural. But behind all the skills, there are concepts. I wouldn't want students to have to go back to first principles on absolutely everything that they do. I just don't think that's valuable. But on the other hand, I wouldn't want them to only have an enormous set of procedures that somehow they have to bring together in order to get answers to questions. So I think that there are some interesting combinations. I sort of want a matrix of the aspects of skills and the aspects of concepts that
I'm feeling a bit underqualified. There must be people who've written using those words or using similar words and actually attempted at least to give written definitions of what it means for something to be procedural and what it means to be concepts. Perhaps it's more usually done in terms of problem solving versus exercises or all these kinds of things, but there's a lot. I don't know if you know anything in particular that would actually try and define this in a way that might actually be applicable.
I would quite like to do an exercise on this, and I don't know if I have time to do it at the moment, because I've got too much to do. But it would be quite nice to have the list of questions that you've just given us, and then really try to unpick them in terms of, I mean, we did it for the first one, didn't we, in terms of the different things, you know, when you were saying, you've got the BODMAS, it's not just BODMAS, it's this, and it's this, and it's this, and it's this. And if we looked at those various bits and really tried to analyse what is needed to answer such a question, I think we could then get into the skills and the concepts and maybe have some kind. I have this vision of a matrix, and I'm not totally sure what it looks like, which is why I think that might be quite a nice exercise to do.
Can I suggest that I email the PowerPoints to you, file, and then just identify the skills that are required to answer the question for? That's a big deal to us.
Yeah, I'm not doing that. Sorry, no offence, but that's a big question.
It's voluntary.
You can send it,
Yeah.
and I'm not promising. I've got too many other things around.
That's useful from the point of view of somebody. I think I would welcome another hour like this
the algebra one though. There's if you come across Lynchevsky's work and Dreyfus and stuff on algebra and all that kind of stuff, because a lot of that structure sense type thing. What do you recognise is?
Thank you very much for coming. I appreciate it.
Thank you.
Well done, Sam.
Cheers, Sam. Very interesting hour as well. Yeah, that might be useful for that.